What's up everyone, my name is Outrage, and I'm going to show you how you can implement a procedural aim-down sight system into your project. So, as you can see, I'm using a modified third-person example project instead of the normal first-person example project because the ADS code doesn't work in the first-person example project for whatever reason. So, what do I have in my project here? Well, I have a weapon blueprint, I have an optic, I have the third-person character, and I have a crosshair widget, which will just show us the center of the screen. So let's get started on this ADS code. To start, what we're going to want to do is save the default transform of the arms. So we can simply get the relative transform, and we can promote this to a variable. I'm just going to call this default. I spelled that wrong. Default arms transform, sure. Again, call it whatever you want. That's what I'm going to call mine. So, moving on, we need to create an input for our aiming. So let's do right mouse button. When we press it, we're going to want to create a new timeline here. So let's do timeline. Add timeline. We can call this aim. Now open this up. Create a float track. It's going to be called alpha length 1, 2 keyframes. First one is at 0 and 0. The second one is at 1 and 1. Scale this to fit. If you right click on one of the keyframes and then hit auto, you get this nice kind of easing curve for your ADS timeline. Go back to the event graph. We're going to drag off our update function here, and we're going to set relative transform on the arms. I'm sorry, that should be set. No? There we go. Set relative transform on the arms. Hook that up. Our new transform, we're going to drag off this, get a lerp. Alpha goes in there, like so. And compile and save. So you notice that we have a couple of errors. We need to set up our lerp here. So the first thing we're going to do is create our ADS code that will give us the transform for our arms. So let's create a new function. We can call this calculate ADS transform, compile, save. The first thing we're going to need is our weapon. Hold control to get it. We want to get the skeletal mesh, and then we want to get socket transform, and this socket name is going to be, for me, it's aim point. It's the same socket I set here, and make sure this is in world space. We want to get the arms. We want to get world transform. Now, if you wanted to, for the arms, you could get the socket transform of the root bone. Both of these do the exact same thing, but get world transform, like I have it right now, for the arms requires a little less work, so we're going to go with that. We're going to make this socket transform of the aim point relative to the arms transform, so make relative to the arms. Okay, like that, and then we want to invert it, add a return node, a return node, and hook this up like that. So you're probably wondering, what this does, how this works. Well, essentially, this code will place a point on the arms mesh, and that point is offset from the root bone of the arms mesh by a certain amount, and that is this transform value here. So if we take that offset, or this transform value, and we simply apply it to the arms mesh, the sight, or this socket here, will be centered in the middle of the screen. Okay, so let's head back to our event graph here, and we need to set up these A and B pins. So for the B, we can just call our calculate ADS transform function, plug in the return value. For the A, we're going to get a select, and we don't have a condition yet, so that is going to be an is aiming variable. So simply create a boolean is aiming. We're going to set it when we aim, set it to true when we aim, and set it to false when we stop. I'm going to hook it up like so, and then obviously add our condition to the select. If we are aiming, we're going to want to get the relative transform, of the arms, because there we go. So we're going to want to get the relative transform of the arms because they're going to be in the ADS position. And if we're not aiming, we can get the default transform of the arms like so, and that should work. And it does, but you might not think it does because, well, the camera is obviously clipping through the weapon, and this is not very helpful. This is not what you want out of your aim down sight system. So we're going to hit escape. Now what you could do is move the socket back. That would definitely work. However, we can do this in our function here. So let's open up our calculate ADS transform function, drag the return node off to the right. We're going to alt click the return value to delete that line thing there. So if you drag off your return value from the invert transform here, you break the transform, drag off our return value from the return node, make transform, hook up rotation, hook up scale, split the struct pin on both sides for the location, hook up Y, hook up Z, X, add a float, 30 works for me, so I'm going to do that. Now obviously you would set this on a per weapon basis. For a rifle, you have a stock, it's in your shoulder, sight's a lot closer to your eye than say you had a pistol where your arms are extended, sight is a lot farther in front of your face. But if we were to play the game now, you can see the sight is in the center of the screen still, but it's farther away from the camera and it's not clipping into the weapon. Now if you don't believe me that the sight is actually centered in the screen, and because it does look a little off, I'm not gonna lie, that's just the sway of the animation. You don't believe me? There you go. That's perfectly centered. So let's say you wanted to have an optic sight, and that optic aim point is not going to be on the weapon. It's going to be on your optic mesh, as like I have here. Obviously it's called aim point, same thing, and it is right in the center. It's not pulled back at all. So you want to have an optic like that. How would you do that? I will explain that, but I'm also going to explain hybrid sights. So say you have a sight on the side of your weapon and you want to turn it to the side so you can get that side optic. I'm going to cover how to do that as well right now. So the first thing you want to do is you're going to want to have an optic set up with an aim point. Make sure this socket on your optic for the aim point is called the same thing that it was called on the weapon mesh, just for simplicity's sake. And obviously make sure on your weapon you have a socket for the optic. I have mine set up that when I press H, it will toggle an optic on the side of my weapon mesh. So the first thing we have to do now is create an input for cycling the optics. So let's create, let's do key E. It's here somewhere, there we go. So when you press E, we're going to set a variable called B cycling sights. We could do cycling, whatever. Set that to true when we press, and I want to do this on a flop, true and false, like so. So I'm actually going to rename this variable to cycled, and that will make sense in a second, but I spelled it wrong. There we go, cycled sights. I think it's still wrong, but you get the point. So let's open up our ADS transform function here, and we're going to alt click our target pin on the get socket transform for the aim point. I'm going to drag this code over to the side, get a select, and then we're going to take our cycled sites boolean. That will be our condition. And if we have cycled the sites, then, well, if we have not, we can use our skeletal mesh, get the aim point. This means we're still using the iron sites. However, if we have not, we want to get the see, you want to get the optic. You want to get the reference to your optic actor, and you want to get the mesh, whatever that may be. Now, I assume in your game you've done this your own way, so this is kind of the basic idea of what you're going to want to do. Set it up something like that, and yeah, that should be that. And then we just go back to the event graph, take this code right here, drag off of our booleans. We want to do a branch, see if we are aiming, because if we're aiming and we're cycling the sites, we want to, well, flip the weapon onto its side so you can aim through the second socket. We'll see here. So if I hit H to show this optic, I aim, and I hit E, you can see we are cycling sites like so. So there you have it, everyone. That is a fully functioning procedural aim down sight system. So have a good one, guys. Thank you for watching, and I'll see you in the next one.